if we're looking here at part D, let's see here. We've got, so just to give people, if you weren't working on this one last night, even though you should have been, basic rundown, we're trying to name an elephant or something, and there's people putting entries into a box, and E of T is the number of entries in the box, not the rate, but the number of them. And we want to know for part D, at what time the entries are being processed most quickly, and we're going to use this P of T value here, which is the rate at which the entries are being processed. So we would know that the entries are being processed. Let's see here. Let's see what we got. Yeah, I gotta read through it here for a second. Process. Okay. All right. So the process will be, or the entries will be processed most quickly when that function P of T is at a maximum. And so we just need to figure out when P of T is at a maximum. So first off, we'll look for when is P prime of T equal to 0. And then, so you can do that in a couple of different ways. I mean, I think what I would do is I would just say, all right, P prime is 3T squared minus 60T plus 298. And then since this is a calculator question, I would just have the calculator tell me when that's equal to 0. And if I were to, let's see here, let's put this into Desmos real quick. So what did I just say that was? It was 3x squared, right, minus 60x, or minus 60x, they were t's, but plus 298. And so we'd see that that happened at 9.184 and 10.816. And then we'd probably even note, if we look at the graph of it, we'd know that the max could only occur when the derivative is going from positive to negative, because when the derivative is going from negative to positive. Hold on a second. All right, sorry about that. So the derivative goes from positive to negative at 9.184. So this is a local max. The derivative goes from negative to positive at 10.816. So that's a local min. So the only one we really need to care about is 9.184. Then we also need to check both of the endpoints because this is a closed interval. And so we'll ignore 10.816. We'll look at t equals 8, and we'll look at t equals 12. And we will just plug each of those in to see what P of 8, P of 12, and P of 9.814 all are. And whichever one comes out to be the largest is when it's being processed most quickly. Does that make sense to everybody?
Yes.
And let's see here. According to the scoring guidelines, at t equals 8, it's 0. At t equals 12, it's 8. And at t equals 9.814, no, 184. That's 184. Well, whatever. 184. It was 5 point something. And so t equals 12 would be when they're being processed most quickly. Everybody good there now? Any questions on part D? Anybody have any other questions on anything else before we start the quiz? Start recording. So now we're recording this one. Anyway, we said when x is -1, we had the slopes of 0, then we plugged the rest in, then we sketched the graph. All right. I just said that for the recording. So part B. And the scoring guidelines here is 1 point for the 0 slopes, 1 point for the rest of the slopes, and then 1 point for the solution curve sketch. All right. Part B, it says that this is defined for all points in the xy plane, describe all points in the xy plane for which the derivative is equal to -1. So we would say dy dx equals -1. And so that means that x plus 1 over y is -1, or that negative y equals x plus 1, or that y equals -x minus 1. So effectively, that would say that everything on here that has a slope of -1 falls perfectly along the line y equals negative x minus 1. And that would be a good enough description of all the points in the plane for which that's true. Does that make sense to everybody?
Yeah, it does.
Wonderful. And that was just worth 1 point for that one. Hold on 1 second. Sorry about that, everybody. All right. Part C just asks us to find a particular solution given the condition that f of 0 is equal to -2. So first thing we'll do is we'll separate the variables. We'll have y dy equals x plus 1 dx. Yeah, y dy is f plus 1 dx. And then we'll just integrate both sides of it to get y squared over 2 equals x squared over 2 plus x plus some constant. And hopefully you're all easily enough able to get that far. And that's worth 3 points already. 1 for separating the variables, 1 for the correct antiderivatives, 1 for having a plus c. And then they give you another point for using the initial condition, which was, I believe, when x was 0, y was -1. Is that right? No, it was -2, sorry. X was 0, y was -2. So we'll solve that and get that our constant is 2. So we'll have y squared over 2 equals x squared over 2 plus x plus 2. And that's the 4th point for finding your constant. And then your 5th point comes for solving for y. So we'll multiply everything by 2. And then this is the part that's important here. When we square root, we end up getting either the plus or the minus. Right? It could be positive or negative square root. And we need to choose the one that makes our initial condition true. Well, our initial condition said that f of 0 is -2. So when I plug in 0 to this, I need to get -2, which means I'm going to need the negative square root out in front to make this true. Does that make sense to everybody?
Yeah.
Wonderful. to answer your question, Nick, the microwave, my older son heating up pizza.
I was guessing nachos.
Nachos? No, leftover pizza. Good try, though. All right, so somebody also asked me to go over the question number 22 from the 2012 test. We'll do that one next. So give me 1 second here. Let me pull that up. Sorry, my laptop's having some issues today. All right, number 22. So this is number 22 from 2012 multiple choice. Given the function f of x equals ln x over x, we want to find the absolute max of f. So in order to find a max, we need to take a derivative. So we'll look for f prime of x. And since this is natural log of x over x, we'll use the quotient rule. It should be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Everybody good with that as the derivative, and that simplifies to 1 minus ln x over x squared?
Yes.
Great. So then we will take a look at the critical values. Critical values are when the derivative is equal to 0. So that'd be when the numerator is 0. Or when it's undefined, which would be when the denominator is equal to 0. So obviously that x squared equals 0 gives us x equals 0, and this gives us ln x equals 1 or x equals e. So we have two possibilities, but if we think about x equals 0, this, if I try to plug that into my original equation, I get the natural log of 0, which is undefined, and I get divided by 0, which you also can't do. So this is not in the domain of f of x, so we can ignore that value. Ln x over x is only defined for 0 to infinity, non-inclusive on the 0. So x equals 0 couldn't possibly be an absolute max because it's not even defined on the function. So the only places we might have an absolute max is at x equals e, or as we look at choice e, it may not have an absolute max. So what we need to do is we need to go in and we need to take e, and then we'll put 0 here and make sure we choose a value between 0 and e, and then something larger than e, and test it into our derivative, into our f prime, and see if we end up with something that is positive or negative. So if we plug in something like 1 is between 0 and e, we get 1 minus ln 1. That's 1 minus 0, so that's positive 1 over a 1 squared is positive over positive, which tells us this is positive here, and the function is increasing. And we also need to make sure that it's decreasing after e. So plug in something like, a million. Well, the natural log of a million is a lot more than 1. So 1 minus natural log of a million is negative, divided by a positive is negative. So it's decreasing. And so this tells us that this has a max at x equals e, but that is obviously not the answer because that's not one of our answer choices. The absolute max is the y value, so we need to find what is f of e. F of e is ln of e over e, which is 1 over e. Choice B. Does that make sense to everybody? Cool. All right, any other general questions? let's take a look. Maybe I got one more here. Let's see here. Yeah, number 24 from that same test. So let's see here. So 24 says g is the function x squared e to the kx. K is a constant. We want to know for what constant, k, does g have a critical point when x is 2/3. So we're talking about finding a critical point of g. Only way to find a critical point of g is by finding g prime. So first thing we'll do is look for g prime of x. G prime of x ought to be using the product rule. X squared times the derivative of e to the kx, which you use the chain rule for, which becomes e to the kx times the derivative of kx, which is k, and then plus the derivative of x squared, which is 2x, and then times e to the kx. And there are no values that make this undefined, right? I mean, doesn't matter what k is. K is any constant. I can take that constant and multiply it by some number that I've squared, and I can do e to any power and multiply all those together. And same with the second part of it. All those things can be done for all real numbers. So we're really just looking for when does this equal 0. Best thing to do to figure that out is to factor out the x e to the kx that they both have. So if I take out x e to the kx from both of those, this one leaves me with kx, and this one leaves me with plus 2. And we want to know when is this equal to 0. Well, we're talking about when x is 2/3, so that'll be 2/3 e to the k, 2/3 e to the 2/3 k times 2/3 k plus 2. And 2/3 is never 0, and e to any power is never 0. So none of this first part will be 0. The only thing that could equal 0 is this. That should be a k. I don't know why I wrote an x there, but that should be a k. So 2/3 k plus 2 needs to equal 0. And looks like that gives us, if you bring that over, that's -2. Multiply by 3 is -6. Divide by the 2 is -3. Does that make sense or no?
Yep.
Cool. Any other questions from any of those practice tests or anything else in particular? All right. Let's see here. Let's see if we can really quickly pull up an area of volume 1 that we haven't done. Let's see if I can find one down here. Does this look like one we've done?
I don't think we've done this one.
All right, let's do this one then. So we'll just work through it together since we only got about 10 minutes left here. So first thing we want to do is write an equation for the tangent line to f at x equals 1/2. So now that should be pretty straightforward. We want an equation of a tangent line. That's just, you need a slope and you need a point. So we need the point when x equals what half? That'd be 8 times 1/2 cubed, which would be 8 times an 8, which would be 1. So we're looking at the point 1/2 comma 1. And then we need to find the slope when x is 1/2. So that means we need to find f prime of x, which ought to be 24x squared. And if we're going to evaluate that at 1/2, that becomes 24 times 1/4, which is 6. So our tangent line ought to be, using point slope form, y minus 1 equals 6 times x minus a half. Everybody good with that or no?
Yes.
Okay. All right. So part B says to find the area of region R. So if we're looking for the area of region R, all we need to do is the upper function minus the lower function, and then integrate it from 0 to x equals 1/2 where they intersect. Which one is the upper function? F or G?
G.
Yeah, G ought to be our upper function. We should be able to tell that pretty easily. I mean, one, because we know that 8x cubed should look, like this, which I'm not going to have this little maximum there. But also, we already found that the slope at 1/2 of f was 6. I mean, clearly that's this one, not this one. So we know that we're going to do sine of pi x minus 8x cubed. So for part B, it should be an integral from 0 to 1/2 of sine pi x minus 8x cubed dx. Hopefully by this time you've gotten to the point where you can do these u substitutions in your head pretty easily. What is the integral of sine of pi x? Okay, apparently we haven't gotten to that point. So what's that?
Negative cosine x over pi, cosine pi x over pi.
That is correct. We're going to write out the u sub though, because it seemed like people didn't immediately have that value. So if u is pi x, then d will be pi dx, which means we do need to put in a pi here and a 1 over pi. It means we got to separate it into two different integrals then, because I'm not multiplying the 8x cubed by pi, right, and putting the 1 over pi out in front. I mean, I could, but that's going to complicate things unnecessarily. Separating into two integrals is going to be best for us. So we'll end up with 1 over pi times the integral of, now this becomes 0 to pi over 2 of just sine u du minus, and then we can integrate 8x cubed right off the bat. That should become 2x to the 4th from 0 to 1/2. And then we'll integrate this. Integral of sine is negative cosine, so we got negative 1 over pi cosine u from 0 to pi over 2 minus, and then we plug in our 1/2 here. And what does that come out to be? 1/8. And then we'll evaluate this. Negative 1 over pi. Cosine of pi over 2 is 0. And then the cosine of 0 is 1. So minus 1. And then we still have our minus 1/8. And so we end up with negative 1 over pi times negative 1, which is 1 over pi, minus 1 over 8. Good or no? Any questions there? Any issues with that one?
Nope.
All right. And lastly, we are going to take this and revolve it around the line y equals 1. And so if we're going to revolve this around the line y equals 1, we need to use washers for this, because the region that we're revolving around that line is not fully pushed up against it. So for part C, it ought to be pi times the integral from 0 to 1/2 of the outer radius. And so the outer radius is from 1 to the lower function. And so this height of the lower function is always just going to be f of x. And the whole distance is 1. So the radius, which is the difference between those, ought to be 1 minus f of x. So we'll square that, and then minus, and then we'll do, again, 1 minus, this time g of x squared dx. Same concept, right? That this height from here to here is g of x. And so the radius part of it is 1 minus g of x. Everybody good with part C?
Yeah.
Cool. Anybody have any other last second questions here on anything? Cool. I know I went over this before the May 4th test, but in Google Classroom, you will see, and I'm going to go to it right now here. In Google Classroom, number 1, where is my Google Classroom? There it is. Number 1, these are the links to the 3 different videos I recommend you watch. I definitely recommend you watch the first 2. Okay. I definitely recommend you watch the first 2. And then the third one would be good also, but for sure watch the first 2 before the test on Monday if you are taking the test on Monday. And then next thing, if you're at 11th grade and you didn't do the math test thing on Tuesday, whatever day it was we were supposed to do it, make sure you follow that link sometimes this weekend and just do that test. And then let's see here. Further down, there are 3 documents in here that I really think you should look over and review. I'm going to talk about all of these once again, even though we already did before the May 4th test. I'm going to talk about these 2 documents up here, the stuff you must know and the exam tips. I'm going to talk about those tomorrow in the review session, but if for some reason you can't make it to that, read through all of this. And then this bottom document here, A/B test reminders. This is something that I compiled. The other 2 up here are things that I got from other people that used to teach calculus before they left our school. This one, I put this one together myself. It's like 8 or 9, 10 pages, I don't know, something like that. That just sort of outlines everything you need to know for the AP test for this class. It doesn't have like practice problems in it. It just has like the information. So it's kind of just a comprehensive guide to everything we've done this year and specific things we need to know, you know, like when a left Riemann sum is an under or an overestimate, or when using a tangent line gives you an under or an overestimate, or how to determine if the speed is increasing or decreasing, or assorted things like that. So hopefully that will all be helpful to you. Hopefully you will all be able to attend tomorrow. I believe it's from 5 to 7, I think is what I said. Yep, 5 to 7. So hopefully you'll all be able to do that. If not, the video will be up within an hour or 2 after that. It'll be up Saturday evening sometime, just depending on how long YouTube takes to deal with it. And there was, let me see, there was something else here in the chat. The question was, how does the multiple choice on AP Classroom compare to the multiple choice on the past tests? I would say that it's pretty similar in general. I don't think it's any more difficult or any easier per se than the problems you'll probably see on Monday. But still, I think your best bet is to go through any of the, and to do all the multiple choice from 2012, 13, 14, 15, 16, whatever years I've got up there in the Google Drive, do those ones first, and then worry about the ones in AP Classroom if you have extra time.